So again, we're still talking about transformations in our warm-ups. We're talking about transformations of parent functions and quadratic functions. So you have a transformation here of a linear function, and then these two are quadratic functions. Okay, so continue to work on those. We'll go over it in just a minute and make sure we get it down again. Guys, some of you have not been turning in warm-ups on Fridays, or if you have been turning it in, you've been turning in like 2 days worth. Okay, that is not good. They are 20 points. They're worth 20 points every day. So Monday's worth 20 points. If you don't turn in Mondays, you're automatically on an 80. Okay, Tuesdays is worth 20 points. So if you skip Monday and Tuesday during your warm-up, you're automatically at a 60. Okay, so we can add up and take off points pretty quickly. All right. So make sure we are doing our warm-up. Because I've told you all multiple times that you will not pass this class if you do not attempt your warm-up. And again, we go over it every single day. So you should have the right answer every day. We go over it. All I ask you to do is attempt it. Alright, so let's talk about our warm-up here. Number 1 says, describe the transformation of the linear parent function. Okay, the linear parent function. So what is our parent function for a line? Someone raise their hand and tell me, what is the parent function for a line? Remember, it's like our starting point. What is the parent function for a line? Y equals x, thank you. Y equals x. Again, that is where all of our transformations start. We start at the parent function y equals x, right? What is my slope for this parent function? Remember what's understood. It's right in front of this x. 1, right? We just don't see it because anything times 1 is itself, so we don't have to write it. Right? So I have a slope of 1 over 1. What's my y-intercept? What's being added or subtracted on at the end of this parent function? Dane, what's my y-intercept? Of the parent function. It goes through the origin, so what's my y-intercept? 0, right? Okay, so we start with a line that goes through the origin. It has a slope of 1 over 1. Okay, and then here it's been transformed. Okay, so it's being shifted. So we want to talk about how is this parent function, how is this line shifted? Okay, so in this problem there is 1, 2, 3, 4 different types of transformations happening to it. Okay, so let me see here. Dane, you're going to tell me about the negative. Okay, Cassidy, you're going to tell me about, you're going to tell me about this 2. Okay, Maritza, you're going to tell me about this -6. Okay, and then Marshall, you can tell me about this +8 at the end of it. Okay, so let's start with the negative. Dan, what is this negative going to do out front?
It's going to make it reflect the x-axis.
Good. It's going to reflect over the x-axis, right? That's like a negative in my A spot. Well, if your A is negative, it's going to reflect your line over the x-axis. Very good. So our first transformation is a reflection over the x-axis. And again, guys, it's important that we get those keywords in. I told you on your test, okay, when we start talking about transformations, okay, it's not going to be multiple choice. It'll be short answers. So you're going to have to actually write this out. So you'll have to write reflection over the x-axis. If you just put reflection, I'm going to count it wrong because, okay, is it reflected over the x? Is it reflected over the y? Okay, so you got to be specific. So this is a reflection over the x-axis. Okay? And then this 2 right here, Cassie, this 2 being multiplied out front, what is that going to do to my line? Okay, now we're talking about letter A. You're right on the vertical. Okay? So it's going to be a vertical stretch by 2. Very good. Vertical stretch by 2. And again, if A is greater than 1, it's a vertical stretch. Okay, we're not looking at this negative. We know that's just going to reflect it. But that 2 is going to vertically stretch. Okay? This -6 inside of the parentheses, who did I assign that to? Maritza? Is that you?
Yeah.
Okay, what is this -6 going to do?
It's going to like move it to the right.
Okay, it's going to shift to the right. Okay, why is it the right, not the left? Because it's negative. Remember, if your C is negative, it's going to shift you to the right. So this one will shift us right 6 units. So write 6. And then lastly, at the end of this thing, Marshall, this plus 8, what is that going to do to my graph? Up 8. Okay? So again, that's transformations of this linear parent function. We started with y equals x. Okay, then it was reflected over the x-axis. Then it was vertically stretched by 2. Okay, then it moved to right 6, and then up 8. So a lot of moving pieces right there. Okay, very good. Number 2, describe the transformation to the quadratic parent function. I forgot my square. There it is. Okay. Again, the transformations are the same. We're just doing it to a different type of function. So instead of a line, okay, our shape of a quadratic function is what? We talked about it yesterday. What is that shape of a quadratic function? Parabola, right? It has that U shape. Okay, so, but the transformation, your A, B, C, and D still does the same thing. Okay, so let's talk about this 3 right here. Okay, so we could read this as 3 times x squared minus 9. Okay, now notice, what's the difference between this 3 and this 2? This 3 is inside the parentheses, right? This 2 is outside. So if it's inside the parentheses, what letter is that? B. Letter B. Okay, now remember, B is backwards from your letter A, right? Instead of vertically stretching or compressing, we're going to do a horizontal stretch or compression. Okay, so we know it's going to be horizontal. And since B is greater than 1, right? 3 is greater than 1. Is it going to be a stretch or compression? Compression. But what number are we compressing it by? What's our factor? By 1 over 3. Very good. Again, you take the reciprocal of that number. Okay? And then our last transformation to this quadratic is this minus 9 at the end. Okay? What is that minus 9 going to do? Shifts down 9, right? It's in the letter D spot. D shifts us up or down, and since we're subtracting, it is down 9. Okay? Very good. Alright, let's do number 3. This time we have 1, 2, 3 transformations going on. Okay? Let's start with this negative out front. Okay? Again, let's deal with that first. It's like a negative 1 for A. Okay? So you're multiplying by a negative 1. Now notice we're multiplying outside the parentheses, so what letter is that? A. Okay? If my A is negative, what's going to happen to my line? Okay, we're going to reflect it over what? So now, okay, my graph or my parabola goes from looking like this to now looking like this. Well, what do we reflect over? The x-axis, right? So this negative out front reflects me over the x. So reflection over the x-axis. Again, you have to specify. Okay, your test will be short answer right here. You've got to specify. Okay. Next, let's take care of this 1/2. Okay, so 1/2 times x. Okay, what is that going to do to my parabola? Well, we're multiplying inside the parentheses. Okay, so again, if it's inside, what letter is it? B. Okay, so we know B is either a horizontal stretch or compression, right? Now, if B is between 0 and 1, right, you get that fraction or a decimal. If it's between 0 and 1, it's going to be a horizontal what? Stretch. Okay, and then by the reciprocal of that number. So this would be a horizontal stretch by 2. Okay, and then lastly, we have this plus 8 inside of the parentheses. Okay, what is this going to do to my parabola? It's going to do shift left 8. Very good. Again, it's in the letter C spot. C is going to take my line on my parabola and just shift it to the left or right. Okay, since I'm adding 8, this one is going to go left 8. Okay? How are we feeling about transformations? Thumbs up if you're feeling good. Okay, thumbs to the side if you're like, eh. Thumbs down if you're still lost. Come on, I should see everybody's thumbs. Thumbs up if you're good. Thumbs to the side if you're like, eh. Thumbs down if you were not getting it. Okay. Again, we're going to continue to do these on our warm-ups. So we're kind of moving away from it, transformations in our lessons because we've got more things to cover. But we're going to continue to go over this in our warm-up because when it comes to test time, okay, I don't want us to go, well, we haven't seen this in 2 weeks. Okay, so we're going to continue to look at some of these in our warm-up. So you can put your warm-up away. You need to get out your journal. Again, we talked about it last week. I gave everyone a journal if you didn't have one. so everyone should have one. We're going to take a few quick notes, and then we will get to some practice problems. Okay? So get out your journal for me. So you're going to turn to your next open page. We're still in Chapter 2, Section 2. Okay, so you're going to title this 2.2 Notes.
Okay.
Yes. Who else can take? And before we start something, just a minute. Okay, 2.2 Notes. Okay, so again, we've kind of moved away from transformations. Okay, Chapter 2, Section 2 is still talking about quadratics. So we're going to be dealing with our parabolas. Okay, yesterday we took some notes over key features of parabolas, right? We talked about domain and range. We talked about the vertex. We talked about the axis of symmetry, x and y intercepts, right? So let's review that real quick before we get to our assignment. Again, everything I write, you need to write. So if I do a journal check, okay, I'm going to look at 2.2 notes, I can see, hey, what did you take notes on that day? Okay, so 2.2 notes, let's talk about it. First off, okay, let's review our parabola. So our key features of a parabola. Again, a parabola has this upside down U-shaped if it's positive. Okay, and then if our x squared is going to be negative, it'll reflect over that x-axis and make it upside down U. Sorry, so a positive x squared looks like a U. Okay, a negative x squared will reflect it right with that negative a. It'll be an upside down U. Okay, so we're talking about these parabolas right here. Okay, so let's just look at this first one. Okay, we're going to take some notes on it. The first thing I want to talk about is, let's start with the vertex. Right, who remembers what my vertex is? My min or max. Okay, so it's either my highest point or my lowest point on the graph, right? So this vertex is the highest or lowest point on your graph. Okay, and so if I ask for the vertex, you're going to give me that ordered pair. You're going to give me either that highest point or that lowest point on the graph. Okay, and if it is your highest point, what do we call it? The maximum, right? So my highest point is the maximum, which makes sense, right? So if it's the highest point, it's a maximum. So that would be when my graph, my parabola, has been reflected over the x-axis. Okay, so it kind of looks like a mountain peak. That would be my vertex. It's that highest point on the graph. So if your parabola is an upside down U, you'll have a maximum. Right? And then my lowest point on the graph, what do we call that? A minimum. Good. You'll often hear me just call it max and min. So if you hear me say max, I'm talking about maximum. Hear me say min, I'm talking about the minimum. Okay. Tomorrow, I'm going to show you how to put a quadratic function in your calculator and then find the max and min using your calculator. I'll show you how to do that. Today, I still want to solve it by hand. Be able to look at a graph and see, hey, there's my vertex. Okay. And again, your vertex is either the highest or lowest point on the graph. So just a quick picture for your minimum, what that would look like, right? We have our U-shaped, and notice that vertex is that lowest point on the graph right here. Okay, so here's my maximum. It's when I have the upside down U. Okay, here's my minimum when I have the regular U. Right, my parabola would be positive in that case, or my x squared would be positive. It has not been reflected over the x-axis. Okay, so we talked about the vertex. And then again, I told you another key feature kind of correlates with the vertex, right? Because it kind of goes through the center of it, or it goes through that vertex point. Anybody remember what we called that? That was not a good explanation. But let's say I have this parabola right here, and you have this dashed line going down through your vertex. The axis of symmetry, right? Okay, so let's talk about your axis of symmetry. Again, what does it mean for something to be symmetrical? What does it mean if something's symmetrical, right? Yesterday I came up here and I drew a square, okay, and I showed you, hey, it's symmetrical. Vertically, it's symmetrical. Horizontally, what does that mean? It's the same, right? So the left side mirrors the right side, or the top mirrors the bottom, right? If I was to fold it along that axis of symmetry, okay, they would overlap. If I was to take this parabola and fold it